Hi, my name's Darren Lynch. Today I'm going to be talking about preparing pump geometry for a CFD simulation in the SimScale platform. So what we've got is this generic pump. You can see that on the screen. And what we typically start with is two separate parts. One part that represents the casing, and another part that represents the impeller. Okay, and there's two things that we've got to do to actually prepare this for CFD. Okay, now it's important to note that although I'm using Onshape to prepare this geometry, you can in fact use any CAD tool that you've got available to you. Okay, it's the logic here that is the main outcomes from this video. Okay, so if you apply this logic to your own processes and your own tools, then you'll end up with the same results. So what we've got to do is we've got to start by creating some sort of flow volume. Okay, now someone once described that to me as if I took this this shape and I capped the inlet and the outlet, so I completely covered them, and then filled the geometry up with water. Okay. If I was able to take everything but the water away, what would that volume look like? Okay, so what would this volume of water look like? So that is what we're after doing as a first step, getting this liquid or fluid volume out of this geometry. Because in the end, that represents what we're trying to simulate in fluid flow. So we're trying to simulate what the fluid is looking like, and therefore this is the most important part. So to do this, I'm actually going to start by creating a sketch on this end face. Okay. What I'm going to do is I'm going to draw a box around the entire thing, and then I'm going to Boolean subtract the casing and the impeller away from this this volume, this box. Okay, so that's what I'm going to do. So I'm going to snap to my bottom view. I'm going to create a sketch on this face here, and I'm going to make it big enough to include the entire volume, but I'm just going to stop it at 0, 0, so that origin there. This makes sure, because I've sketched on the outlet face and I'm going up to the inlet face, that when I subtract everything I'm going to get two complete volumes, one outside, one inside, and it's the inside one that we want to keep. Okay. Now I'm not going to constrain this, no point spending time on something that's unnecessary at this stage. And I'm going to extrude that sketch. So we're going to move on to extrude everything in sketch. And I'm going to extrude it well past my original volume. Okay. So that's step 1 complete. So now we have this extra volume, this part 3, that we need to do some operations on. So if I change the visibility of that, just move myself, change the visibility of that, there we go, we can see better into that geometry. So what I'm going to do now is I'm going to subtract both the impeller and this case geometry away from that volume, and I'm going to use the Boolean operation. It might be called other things in your CAD tool, but essentially what we're doing is subtracting a volume away from another volume. So I'm going to go to subtract, I'm going to select the target. What we were doing is we were just subtracting two volumes, so the impeller and the casing, away from this new volume that we created. So let's go ahead and do that now. So I'm going to subtract from the target this new, so the target, what we're subtracting away from, is this new part 3. And what we're going to be subtracting is the impeller and the case geometry. There we go. And I'm going to accept those results. And we notice two things. We've now got two different volumes. Okay, one, as I mentioned earlier, is going to be the inside and one's going to be the outside. So let's just hover over them and find out which one it is. So this one is my outside, so if I hide that, then we're left with a volume. This represents the fluid part that we actually want to be simulating. So if I go back to my original geometry and I capped off the inlet and the outlet face, filled it up with water and took everything away, this is what I would be left with. Okay. So I'm going to delete the part that I don't need, which is this hidden part, this part 1. That's great. And I'm going to rename this one my fluid volume. Great. So we've got one part that is our fluid volume, but that's not all we need to do to make this ready for SimScale, because we need to tell SimScale where this, what in this design is rotating, essentially. And we want to tell it that the impeller part, this bit in the middle, is the bit rotating. But how does it know that when all we're left with is this fluid volume? And the answer, quite simply, is we put some volume around it and say that whatever's inside this volume is spinning. It's very simple workflow, hopefully. And then all we need to do is say, okay, SimScale, this volume is rotating. Do your thing. Okay. So let's go ahead and create that. So the most sensible thing in my head is to create a sketch on this bottom surface. So I'm going to create a new sketch on that bottom surface. If I line it up, we can see that the dead center is this origin point. So I'm also going to use that in my sketch. And what I'm going to do is I'm going to create this a circle from the center out past my impeller. Okay, so let's say I do it to about there. And in this case, I am actually going to constrain it. I'm going to say it's going to be. I mean that might be right. Let's just leave it at that. Good. And finally, what we want to do is extrude that. Okay, to create a volume. So we've got a circle that is slightly larger than your impeller, but it's got to be a cylinder and not a circle. So what I'm going to do is I'm going to come again to my extrude. I'm going to select that circle, and I'm going to extrude it up past my my impeller geometry. And I'm going to have this as a new volume. Okay, so if I bring it up to about there, I think for all intents and purposes that is it's ideal. And the only thing I would change here is actually that there's no need for this this cylinder to be contacting the back of the casing. So what I could actually do is I could move that face slightly. If I first hide the flow volume, I select this rear face. I'm going to move it in, say, to here. And if I revisualize, looking at the side, I think that completely encloses the impeller. Just to be sure, I'm going to edit the appearance and make it a little bit transparent. And there we can see that it is slightly bigger. Now, to me that's too close, so I'm just going to move it out a little tiny bit. There we go. So we've got, to summarise, we've got one volume that represents the fluid. Okay, so if we were to actually fill our volume up with a fluid, what would we have? This is what we'd have. Okay, and then we want some sort of representational geometry to say anything inside me is spinning. That's all the logic we're trying to say here, and that is this cylinder volume. And it would be sensible to name this with rotating zone, maybe, or its technical name, MRF. Okay, there we go. So when we bring them both together, we can see that we have the rotating zone is completely overlapping the fluid volume, and this right here, as it is what we expect in SimScale to actually receive that that geometry. So hopefully that helps you in understanding the process to preparing this geometry for rotating turbo machinery, and enables you to use your own geometries using this workflow. If you've got any questions, then please reach out to us. Thank you very much.